Hello fellow guitarists and studio engineers. I'm going to talk about the sonic signature in the first movement of the consequence of engineered consent. A sonic signature is the unique sound we create through choice of tone, technique, and psychoacoustics specific to that recording. Our choice of instrument, amplifier, and pedal shape the sonic signature while we're performing, as do microphones and their placement while we're tracking in the recording studio. The plugins we choose shape the sonic signature during mixdown and mastering, and our choice of bitrate and encoding shape the sonic signature that devices receive from audio streams over the internet. On this channel, I talk about my original compositions and the audio engineering I use to record them. I avoid advertising, patronage, and product placement, but when I describe a sonic signature, I need to tell you what equipment I use. So I'll narrow product references only to what's relevant to the sound you hear in the recording. I use two guitars in the first movement of Consequence. The first is this Gibson Explorer reissue with a 496R pickup in the neck position. The 496R has what Gibson calls a hot ceramic magnet, but it only has a DC resistance of 8.4K, similar to what we get in some other Alnico humbuckers. Gibson doesn't provide a frequency plot for the 496R, but based on what I know from playing it on other pieces, I EQ'd the amp to moderately boost the bass and treble on this piece. You hear this Explorer when the piece opens. I'm going to run a screen capture of the Pro Tools session so you can hear the sonic signature of the Explorer. Listen for how I use reverb and tape echo to sustain the power chords, and also listen for the telltale repeats from the tape echo on the slide down late in measure 4. Then listen for the chorus in measure 7, where you'll hear some comb filtering. Let's listen to the Explorer now. I'm going to solo the Explorer now so you can hear its sonic signature in isolation. Now I'll unsolo the Explorer so you can hear it in the mix with the second lead instrument introduced in measure 11. The second guitar you heard is this Yamaha 1980s RGX Super Strat with a floating bridge and a locking nut. I put a dimebucker in the bridge position and a Fishman triple play MIDI pickup between the dimebucker and the bridge, so I still get a lot of mileage out of this relatively inexpensive workhorse guitar. The dimebucker has a DC resistance of 16.5K, almost double the value of the 496R. The magnet's also ceramic, and you can see it has stainless steel rails rather than pole pieces. Its frequency plot is scooped, with treble frequencies more than double the bass over the mids. Apparently Daryl wanted a pickup with beef, crunch, edge, and presence with biting treble and a punchy bass, but an overall smoothness. So if the dimebucker doesn't give you what you need in your sonic signature, you're probably not playing metal, at least the way Dimebag imagined it. Let's go back and listen to the mix beginning in measure 11. You'll hear more reverb, more tape echo, more chorus, and more of everything, as we might expect from the Dimebucker. Now I'll isolate the RGX so you can hear its sonic signature better. Now we'll restore the mix so you can hear the signature of both instruments together again. Let's start with effects. Effects pedals contribute significantly to the sonic signature of each guitar. I've already described what the effects do in the sonic signature, so now I'll tell you about settings and configuration. The sonic signature of both guitars include a Strymon Mobius chorus, an El Capistan tape echo, and a Blue Sky reverb in that order, in a parallel effects loop between the preamp and power section of the amplifier. The chorus is a classic analog variable clock bucket brigade effect with a single low frequency oscillator set to 48 megahertz, which is about half the tempo of the first movement. The tape echo, also synchronized to the tempo, models a single tape head offset in position as needed to create the specified time delay. The reverb is a room reverb with very limited pre-delay and modest high and low frequency dampening to control EQ and reflections. Now I'll tell you a little bit about the amplifier. I've had this amp for about 20 years. It's a Mesa F30 with the EL84 Dynawatt circuit like they use in the Mark V series and some other past Mesa products. I struggled to find the right use for this amp until I realized Mesa had incorrectly marketed its voicings and chose the wrong speaker for it. Let me explain. Mesa advertised channel 2 to have a medium gain where, get this, purring blues gives way to rock and roll rhythm and soft clip solo sounds, with a channel 2 contour to infuse a double dose of steroids and pump up the gain to fiery proportions, producing one of the most hellacious crunch sounds around. This grinding wall of gain was inspired by our mighty dual rectifier. Well, the F30's voicings never really lived up to the marketing. In fact, I don't think any amp could cover that wide a range of applications and do it well. And it doesn't even make sense to pump up the gain on steroids, blah, 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 to wind up with a hellacious crunch sound. So recognizing that the Vintage 30 was a good choice only for channel 1, the clean channel, and not doing anything for channel 2, I replaced the Vintage 30 with the mysteriously named Black Shadow, which Mesa also uses in the Mark V combos. The Black Shadow, also known as a Celestion Custom 90, C90, and MC90 by the Mesa marketing team, appears to be a Celestion Classic Lead 80 rebranded and possibly modified to satisfy Mesa's 90 watt requirement for the Mark V series. At 90 watts, the Black Shadow has 30 watts higher headroom than the Vintage 30. It has a higher resonant frequency at 85 Hz rather than the Vintage 30's 75 Hz, and only 1 dB lower efficiency at 99 dB. The Black Shadow better supports the actual channel 2 voices, which are, number 1, an aggressive distortion, not a crunch, with gain easily exceeding a vintage distortion. And that's the voice the amplifier contributes to the sonic signature of the Explorer. And number two, what Mesa calls its contour voice, which adds a boost to saturate channel 2 and some EQ to retain its identity in the mix. The Black Shadow, with its higher headroom, contributes significantly to controlling the low end in the contour voice. This is the voice of the amplifier you hear in the sonic signature of the RGX. Next, microphones change the sonic signature produced by the amplifier according to the frequencies they boost or cut. I use 3 microphones to capture the sound produced by the amplifier, 2 in front and 1 in back. The microphone on the left is an Austrian Audio OC18, a cardioid condenser with a single diaphragm in a ceramic capsule. Its frequency response is neutral up to about 4K, where it is more sensitive to high frequencies by about 4 dB. You'll notice it's about a foot off the grill cloth to reduce its proximity effect. I also set its low-cut filter at 80 Hz to further reduce proximity effect. On the right is a Royer R10, a passive ribbon mic with a 2.5 micron ribbon element. Passive ribbon mics have a lower sensitivity than condenser mics, so I boosted its output by 20 dB with an inline activator before the preamp. Its frequency response is neutral up to about 5K. Above 5K, it's less sensitive to high frequencies by about 3 dB. It's also about a foot off the grill cloth, and because its pickup pattern is also directional, I use a high-pass filter on its preamp to reduce proximity effect. The analog signals of each of these microphones are then boosted by a neutral preamp in the interface before being converted from analog to digital. I won't discuss the preamp because it doesn't add to the sonic signature. I discuss digital conversion and rendering to the digital audio file below. Next, look carefully just above the amplifier handle and you'll see a Crown PZM 185 pressure zone microphone located behind the amp. The PZM captures sound coming from the back of the speaker, reflecting off the floor. The PZM 185 is a surprisingly high-quality microphone with a hemispherical polar pattern. I ran the PZM through a Great River ME1NV preamp. The ME1NV is a transformer-coupled Class A big iron output amplifier. The ME1NV does change the sonic signature of the PZM 185. Iron output transformers enhance the harmonics in a signal to produce what we consider a vintage sonic signature. While the ME1NV adds harmonics to the signal, it's considered a more neutral version of the Neve 1073. Once the amplified signal reaches the analog to digital converters, it's sampled according to the specified bit depth and sample rate. In this case, 24-bit depth and 96 kilohertz sample rate, which loosely compares to a bit rate of 2.3 megabits per second. The sound you're now hearing on YouTube has likely been encoded by the advanced audio codec, the successor to MP3, at a much lower bit rate, likely 128 kilobits per second. Then processed through the AAC analysis filter bank and the AAC perceptual audio coding model. Processing by the filter bank and perceptual audio coding model includes quantization, masking, and noise shaping. AAC rendering is subject to known digital artifacts, a non-harmonic distortion produced during encoding, most commonly loss of bandwidth, pre-echoes, and roughness. So we know that after Google processes a video, the digital audio file associated with the video is not the digital audio file bounced from Pro Tools. Whether the sonic signature we hear after the serialized AAC file is decoded is the same sonic signature produced by Pro Tools has been studied, but not as well as we might hope. Unfortunately, the results of the studies themselves require careful interpretation. I recommend that you familiarize yourself with these studies so that you can form your own opinion. Here are some observations on what you'll encounter. Number one, very few blind tests successfully establish adequate experimental controls required to make sound judgments about the audio files being compared. I provide a link below to ITU BS.116, an international standard which purports to establish those experimental controls. Even a cursory look at the standard will give you a sense of how burdensome the controls are required to run valid blind tests. Very few blind tests satisfy the experimental controls in BS 116. 2. Notice the title to BS 116 is Methods for the Subjective Assessment of Small Impairments in Audio Systems. Even after satisfying the burdensome overhead of the experimental controls, the results are by definition a subjective assessment. Even worse, the judgments listeners are required to make, which are listed as imperceptible, perceptible but not annoying, slightly annoying, annoying, and very annoying, are obviously subjective and undefined in the specification. Number 3, results vary between trained and untrained listeners. Trained listeners are better at differentiating between renderings. The training can be as simple as knowing what to listen for or knowing where to listen to hear a difference. Number 4, some authors use qualified language like small difference or near CD quality to draw unjustified conclusions. I've read articles that claim most listeners will never hear a difference because their equipment can't produce the required frequencies anyway, or that, get this, only musicians can hear a difference. In summary, the literature on blind tests is underwhelming when judged as scientific literature. So I have to recommend that you read some papers and judge for yourself. A good place to start is MP3 and AAC Explained by Karl-Heinz Brandenburg. I'll provide a link below so you can read that paper. Now, if you don't want to read academic papers, ask yourself whether you, as a guitarist or studio engineer, might be likely to hear a difference, where an untrained listener might not. Can I hear a difference between the sonic signature bounced from Pro Tools and the sonic signature from Google's AAC encoding? Absolutely. If you're a trained listener or know what to listen for, it's likely that you can too. Okay, well that's plenty for this video on the sonic signature of the consequence of engineered consent. You can preview lossy audio streams for consequence or find links to the high-res lossless downloads at Random String Records. I'll provide links below.